Hello everyone. Question is, we need to find maximum power delivered by the spring to this block. And what is the information which is given? Block is released from this position. Released. That means it is at instantaneous rest. And what is this position? This position is at a distance of capital A from the natural length. Force constant is given K, and our aim is to find maximum power. Now, why do we ask maximum power in this? And why do we know that maximum power consumption type of thing will take place? We know that power is force dot velocity F dot V. When object is released from this position, it is at instantaneous rest, which means V is 0, and therefore power right at this point is 0. Now, when this object reaches natural length because of the spring force, restoring force, when it arrives at the natural length, it definitely is moving with some velocity, but since object is at the natural length, there is no restoring force acting on it. Force becomes 0, and therefore right at the natural length, power is what? 0. Power initially is 0. Over here it becomes again 0. In between, object is moving and is under a force, restoring force, and therefore F is present as well as V is present. Something which is 0 and ultimately becomes 0 tells us that its value must increase and then decrease. That means at one point its power will be what? Maximum. So the aim of the question is to find maximum power, and we'll see two methods, one the detailed one and the other one a shortcut one. We'll see that later. So how to solve something like this? When we use maxima and minima, we use dy upon dx equals to 0 for y to be maximum or minimum. In this question, you don't have to worry about whether things are maximum or minimum, because I have already given you that P is what? Maximum. And I already told you how it should be maximum, why it should be maximum. Now, whenever you need to maximize something, y, with respect to some other variable, then its differentiation becomes what? 0. For detailed knowledge of this, you can watch the appropriate lecture. But right now, I will assume that you have the idea of maxima and minima. For us, this y is P. We want to maximize power. So we need to differentiate power with respect to some variable. What is that variable? That variable is, in this case, x. Not this x. This x can be anything. This y can be anything. Similarly, this x is also anything. It simply means y as a function of x. Just don't worry about it. You will understand everything. So first of all, you need to write a function of power in terms of x. Which x? Look here. As you release the object from this position, after some time we found that object is present over here. I am showing the object, this block, as a dot. So after some time, we found that the whole setup is like this. Block has moved from this position to this position, and right here its velocity is v, and its deformation from the natural length is now x. From the natural length, position of the object is x. Definitely object has moved a minus x, but when you write spring force, you always write F equals to kx, and in that x is what? Distance from the natural length, and therefore I am using x. So this is the x. At some time, object is found over here, is moving in this direction, and restoring force is also acting in this direction. Spring is pulling the object, it's also moving in this direction. So force and velocity, they both are in the same direction, which tells us simply force V multiplied by cos 0. When you open dot, you need what? Angle between force and V. Direction of force and direction of velocity over here, they both are same, which makes it what? 0. Now, what is F? F is magnitude of the force. This distance is x, force constant is k, and therefore magnitude of F is kx. Just don't take it minus kx. That negative sign tells us what? Direction of restoring force. And once you open dot, we use what? Magnitude. So this is the magnitude kx. Cos 0 is what? 1 multiplied by V. Right now this power is a function of x as well as V. If we can find V in terms of x, then right side will be something which is just a function of x, and then we can start differentiating whole thing. So let's see how we find V. The moment I say friction is 0, an object is released, then it means no external work is being done. The person who was holding the object, he releases the object, his work is gone, he is not doing any work. Friction, it's not present. Normal reaction and mg. Normal reaction is simply balancing mg, and therefore we are not interested in their work. The only force present is what? Spring force. And for that, we will be using potential energy function, which you know is half kx square. That means for this question, W external is 0. And when W external is 0, we use COME. What is COME? Conservation of mechanical energy. Sum of kinetic and potential energy, it will remain conserved everywhere. Sum of K and P at this point, at this point, at this point, at any point, that sum will remain what? Conserved, because there is no external energy coming. Now, how do we use COME? Let's look into this part now. I hope you have drawn the figure and taken all the information from the board. Let's see, how do we use COME? Remember, this is the natural length, and this is the place where object is released from. So when you use COME, you will be writing kinetic energy at both places, you will be writing potential energy at both places. kinetic energy at this position. Object was at rest. So kinetic energy is 0. This is kinetic energy initially plus potential energy. Potential energy initially. What is the deformation? A from the natural length. And therefore, spring potential energy is coming half K A square. And when object reaches this position finally, we say that kinetic energy final, potential energy final is same as initial, which is nothing but CONE. Now finally, over here, object is moving with velocity v. So what is the kinetic energy? Half mv square. What is potential energy? Half k. Right here, deformation is what? X, and therefore this is coming x square. So we have got initial energy and we have got final total energy, and they both are same. You can see that this equation gives us v as a function of x. We'll put this value of v in this, and then we have to differentiate. Now, how do we differentiate and how can we save time? Calculation work. Let's look into that part now. Don't forget to note down this step. So from this equation, your v square is coming half. These things are gone. This is coming k times a square minus x square divided by m. Half is gone. Shift there and you get what? K common, a square minus x square divided by m. Now, normal tendency will be to take the square root and then put this value over here and then go for differentiation. But that will increase difficulty level a bit, and we are not interested in that. Why? Look here. First, let me tell you the kind of difficulty you will face. Not a big thing. If somebody is comfortable with differentiation, they can easily handle this thing. But still, why waste time in that? Somebody who puts the value of v by taking square root of this ends up with this root over k by m a square minus x square. So now we need to differentiate this with a square root. Not a difficult task. You can take x inside and then everybody knows how to differentiate power functions. But the point is, if I say this, when p is maximum, square of p will also be maximum. If you say that there are two numbers, 1 and 2, and 2 is maximum, then square will be what? Square of 1 is what? 1. Square of 2 is what? 4. Again, you're getting the same order. So when you say p is maximum, square of p will also be maximum. So what is square of p? K square x square multiplied by v square. And what is v square? This is your v square, k by m a square minus x square. This is square of p. Instead of differentiating this, which is under the root, Now we have to differentiate this, which is a very easy thing. Now how easy it is? First, let's say p square has a name which is y. It doesn't matter you call it z or you keep it as p square only, but just so that presentation looks good, this p square we have given it a new name which is y. This y is a function of x. What does it mean when I say function of x? If you change x, this y will change. Everything else is what? Constant. A is constant, k is constant, m is constant. So this y, first of all, presented in this form. So you've got k cube divided by m. Take this x square inside. A square x square minus x to the power 4. You don't have to differentiate this, you just have to differentiate this part. Now, for p square to be maximum, that means for y to be maximum, dy upon dx should be 0. Now let's find out this differentiation now. Don't forget to note down this part. And by the way, if you are comfortable with differentiation, you can pause the video at this stage, go for the differentiation, and at the end you can come back and check the solution part. So we are interested in dy upon dx. Constant terms, k cube divided by m. A square is a constant. What is differentiation of x square? 2x. So this becomes a square 2x minus differentiation of x to the power 4 is what? 4x cube. 4x cube. And for y to be maximum, this thing should be 0. That's how maxima minima works. It is giving us 4x cube is 2a square x. For this thing to be 0, this bracket should be 0, which is 4x cube is equal to what? 2a square x. 2 and 4 cancelled, x and cube cancelled, and you got x square as a square divided by 2. X cube, x square, which is coming a square by 2. This gives us x as a by root 2. There is no need for you to take the negative value. Negative value of x corresponds to this side. So we are interested in somewhere between this point, and therefore I am taking x as what? A by root 2. One of the important result for NEET and JEE type examination, you can use it directly. That if you displace something by A and you release it, then at what point maximum power consumption will take place? Normally people answer what? At exactly the middle point. No. What is the answer? A by root 2. A by root 2. So this is telling us what? This is telling us that when x is a by root 2, dy upon dx is 0. If dy upon dx is 0, then it means y is maximum. If y is maximum, then it means p square is maximum. If p square is maximum, that means p power is what? Maximum. So you've got the value of x. Put this value of x in this, and you will get what? Maximum power. Not a difficult task left. You've got the value of x. Put this value of x in this p. That is, first you put value of x over here. and finally take the square root, and you will get what? That power which is maximum. So this is the first method which is coming from work energy, but somebody who has the knowledge of simple harmonic motion can solve this question in just 1 minute's time. So those who have no idea of simple harmonic motion, next part of the lecture is not for them. Once you watch SHM, you will understand everything. But so far, if you have no idea of simple harmonic motion, just don't worry with the rest of the thing we are going to do in this lecture. Everybody who has the idea of simple harmonic motion, he knows that you release the object and then this object is going to execute simple harmonic motion. Simple harmonic motion. And for simple harmonic motion, we know that x is a sine omega t. And those who have no idea of simple harmonic motion, they will find it difficult. Not difficult, they will find, they don't know how do we arrive at this. And once you watch SHM, it's not a difficult thing. You can also develop this if you are interested. If your maths is good, you can still develop this type of thing. You have the idea of force, which is acting on the object. If you have the idea of force, you have the idea of what? Acceleration. If you have the idea of acceleration, you can find what? Position with respect to time. Just remember, we cannot use Newton's equations like v equals to u plus at and all, because those equations are used when acceleration is constant. Over here, as object moves, x changes, force changes, acceleration changes, and therefore one has to use a as dv by dt, and then you will get the answer. But forget that now. In simple harmonic motion, it's a standard result, a sine omega t. If x is a sine omega t, what is v? v is dx by dt, which is a omega cos omega t. By the way, omega is called angular frequency. So when you differentiate sine, its differentiation is what? Cos, and this term of omega comes out. If you don't know how to differentiate sine and cos, you can watch again the appropriate lecture. So you have got v. If you have got v, then we need what? Power. What is power? Power is magnitude of force, magnitude of v into cos of 0. This is, we already know from the first method. What is magnitude of force? K times x, K times x into v. Magnitude of force, v. What is x? A sine omega t. A sine omega t. What is v? A omega cos omega t. Remember this value of x as a upon root 2. This is v. Let's put the value of v. v is a omega cos omega t. Now again, you can pause the video at this stage. You've got p in terms of k sin omega t, a omega cos omega t. Let me just tell you, k is a constant, a is a constant, a is a constant, omega is a constant, and now you can answer this question without any knowledge of SHM. SHM helps us in arranging P in terms of T. SHM tells us that X is this. Once it tells us X is this, then anybody from 11th can solve this question. If I give you X, you know differentiation of X with respect to T gives us what? V. Force we have V as a function of T is present. So this is your power and you need to maximize it. Pause the video, try to maximize it, and the hint is you can use maxima minima but you don't have to. You can but you don't have to. Look here. This P is, I think I can save time if I simply multiply this thing by 2 and divide the whole thing by 2. That save time. This is a hint. Multiply 2, divide by 2. What do you see? 2 sine theta cos theta. 2 sine theta cos theta. So your power is k a square omega divided by 2, which is this, and then 2 sine theta cos theta becomes what? Sine 2 omega t. Your power is a function of sine, and you need what? Maximum power. When P is maximum, this term of sine should be maximum. So what is the maximum value of sine? 1. You immediately got the value of P max. P max is coming k a square omega divided by 2. When is P maximum? When sine its value is what? Maximum. So if you put x in the previous method, you will end up with this. But let's match up the data with the previous method. So when is sine maximum? Maximum of sine is 1. Now the point is, when is sine maximum? Sine 90 is what? 1, which is the maximum. That means this 2 omega t should be 90. 2 omega t should be 90. Which means what? Omega t should be 45 degrees. What does it tell us? It tells us that when omega t is 45 degrees, sine is maximum. When this is 45, omega t into 2, 45 into 2, 90, sine 91, this is the maximum value of sine. P is also maximum. So, when omega t is 45, power becomes maximum. When omega t is 45, what is sine 45? 1 by root 2. So, we got the value of x as what? A sine 45 degrees, which is a divided by root 2, something which you saw in the previous method. This is not the maximum value of x. It is giving us what? When x is a by root 2, power is maximum. And by the way, those of you who want to verify, this is the P max coming from the first method. Just remember, this term omega is root over k by m. How come omega is root over k by m? We'll see that when we handle simple harmonic motion. Hope you understand first method. And from this line onwards, it's not a difficult thing to even understand the second method. Note down everything.